We're looking at here what's perhaps the world's most instrumented plastic pipe. We've got a plastic pipe here that's containing air pressure. We've got air being fed into it through a control valve, and air is venting out through a manual valve. We've got a control system monitoring that pressure using a transmitter right here, and it's making adjustments to the valve to try to keep the pressure stable. So if I take this manual valve, move it open, move it closed, I'll move it open here, see the pressure sag, and then it recovers as the control valve compensates. I'll take the manual valve and close it off. We can watch the control valve compensate as I do. And the control valve pinches down, and it maintains pressure at 10 psi. Well, added onto this, we've put feed-forward control with another pressure transmitter measuring the supply pressure. So even if the supply pressure bumps up and down, we maintain a fairly stable pressure in the tube at 10 psi. So we've got feed-forward, we've got feedback control, and now we've added one more layer of control, and that's a safety shutdown system. We have right here a pressure switch high that's measuring the same pressure that's inside the tank, and if that exceeds 20 psi, what happens is we end up shutting off a solenoid valve that cuts off the air through a control valve. So even if this control valve goes wide open, we can't get any air to the vessel, and the pressure goes down to zero. It's a safety shutdown system. Now that safety shutdown function is implemented through an electromechanical relay, an ice cube relay, and that can be reset remotely through a push button. So let's head over to the controller and take a look at what's happening from this perspective. So right here we are looking at a controller with a set point of 50%, where we are display there of 49.8, that's our process variable, so we're hanging real close to our set point of 50. Our output is about 30% open. So now what I'm going to do is I'm going to force this into a high pressure condition. I'm going to put this into manual mode, and in manual mode I'm going to raise the valve that's at a higher position, and we will watch the air pressure build and build and build. I may have to raise the valve a little bit further. I'm going to force this into a high pressure condition. You can see the pressure right there. If it exceeds 20 psi, the switch will detect that, trip the relay, and that will open up or close the solenoid to shut it down. And there we see the pressure falling off. So the pressure switch tripped, it activated the relay system, that cut off air to the process, and now I can't get any process pressure even if I open up the valve up wide. So we've got ourselves a shutdown system. And now what I can do is go down to the reset button right here and press that button. And there's my pressure coming back up, and I can throw it back in automatic mode and raise my set point. And I can watch it stabilize at whatever desired pressure I give it. So there, we're pretty close to set point. It's coming down, it's controlling, it's stabilizing. So that's a demonstration of our safety shutdown system implemented with a high pressure switch, ice cube relay, that's overriding the regulatory control of this PID controller.